In this tutorial, we're going to be rigging the antenna of this robot. It's going to be fairly quick and pretty easy. It's going to show you how you can use dynamics with joint chains and IK setup so that we can get some nice dynamic and secondary motion. If you open up the file RobotAntenna start, now you should see something similar to this. You can see in the object manager here we've got the hierarchy of all the parts, and it's made pretty much from primitive objects, as you can see. I've also added in some animation, so if we select the robot head, you can see some keys down here in the power slide, and if you press Shift F3 to bring up your timeline, or you can access it from the window menu, you can see I've got some rotation keyframes for the heading and the pitch. Honestly, I'm not going to win any awards for this animation, but it's just to save time. And if we just press play, you can see that as we play through the timeline, we've got this animation of the robot moving his head around. Now, the reason I've done this is so that we can create the rig for the antenna, and hopefully with this motion that already exists, we're going to get some secondary motion as he moves so that his antenna kind of wobble around. And you can use this for all sorts of things. It could be the dog of the tail of a dog. It could be like an aerial on a car, you know, anything that sort of whips around in the wind, any secondary motion, someone holding a flagpole, etc. The way that we're going to rig this is by using a joint chain, and joints themselves don't actually deform objects. They need to be used in combination with the skin deformer, but they allow you to position the joints along your geometry, and you can think of them almost as if they're bones inside a skeleton. So you would position one at the shoulder, and then at the elbow, and then at the wrist, and then at the end of the fingers if you wanted to rig an arm. This is a much simpler example to get us started. It's a dead straight line for the antenna. There are a few issues with working with this kind of setup. Firstly, that we need to make sure our objects are editable. You can rig parametric objects such as this cylinder and this sphere, but you need to use a few workarounds, for instance using another object in a mesh deformer, or a few other different tricks. But for now, we're going to just select these objects, and we can just select the antenna and the antenna end. Let's just press C, and you can see that that then converts them into polygon objects. So now if we switch to point mode, you can see that we can actually select the points on those objects, whereas a parametric object such as the ear, we don't have access to the components of that object. So if we select the antenna, and let's just press F3 to come to our side view, and we can press O to frame it. What we need to do is we need to place some joints, and the trick here is that we position the joints so that they start at the very bottom here, and then the next joint starts here, and the next one here, and the next one here. And you want to try and position them exactly where those edges are, because when the joints all rotate, that's where the deformation will take place. So if you put one in the middle here, there isn't an edge there, it's not going to deform as nicely as if you position them accurately. And there are a few ways to do this, and I'm just going to quickly show you the manual process. So what we can do is we come up to the character menu, come down, and in here we have the joint tool. So as with any tool, you can see in the attribute manager we have the options for that tool. Okay, and we're not going to worry too much about this. We can uncheck root null, which is going to just add in a null object at the root of it. And we've got these modifiers at the bottom here, and you can see that if we press Control, it's going to draw. We can press Shift to split joints in half. We can also use symmetry in here, and then we've got different ways of displaying them. So the other option I want to check here is the projection option. And the projection option, what that will attempt to do is it will try and project the joint so it is in the middle of the geometry. And in this example, that's exactly what we want. So what we want to do is we just want to hold down Control in our viewport, and we just click here, and we just click and click and click all the way to the top until we have our joint chain. And you notice that we had that object selected, and it's created all of these joints as children. If we come back to our perspective view, let's see where they're positioned. Okay, and it's actually done a pretty good job. If we come here, you can see that it's positioned them in the inside there. Let's just switch to our lines mode. Okay, there you go, and you can see all those joints So the joint itself is actually this round axis, and this is a bone that it draws in between. And once we've got these in place, what we can essentially do is we can grab these and we can rotate them like so, and we can use that to deform our object. But you notice then that when I did that, it's not deforming the antenna at all, even though they are children. And this is because the joints themselves don't deform the object. You have to bind them to a mesh. Now, one of the problems with doing it using this approach is that if we select each joint in turn, you can see we've got these kind of arbitrary rotation values, and you can see that each one is set slightly differently. So you may well want to select joint 1 and set that to 90. And then you may well want to go through each of these and set these all to be 0. Okay, and you can see that now that's done that. You can also come up to the character menu, and then we have a joint align tool which you can use to align joints so that they point at the next joint in front, etc. But it's quite important to have your joint rotation values at something sensible before you start, because as soon as you start rotating them and moving them around to deform your object, if you're using some arbitrary value from the beginning, then unless you've keyframed those, it's going to be quite hard to return your object back to its original state. So if you use values of 0 wherever possible, it's much easier to remember to return it back. Very often animators will keyframe all of their joints at frame 0 or even a negative frame, just so that they have all of those rotation parameters stored just in case anything goes wrong and they have to return back to their initial pose. So creating the joints this way is a fairly manual process. As you can see, we placed each one by hand essentially. I'm going to grab these joints and just delete them. Now, there is a slightly easier way in this example. It doesn't always work, but I just thought I'd show you this alternative method. And what we can do is we can select our object here, and if we just come and grab one of the edges, such as this edge here, I'm just going to come to my top view. I just want to make sure that that's on the side it is. It doesn't have to be, but it'd be nicer if it's at the kind of 0, 90 or 180 position. With one selected, we can come down to this very bottom one, hold Shift and Control, and it's going to select all of the edges in between. And that's essentially where we want our joints. With those edges selected, you can choose Mesh, Commands, and then choose Edge to Spline. And you can see that adds in a spline object, and if we switch over to our points mode, you can see that that spline has its vertices exactly on the edge of our geometry. So now we've got a spline here. I'm just going to drag that out of the hierarchy. We can come to the character menu, and we've come to conversions, and here we have the option spline to joints. And as soon as we do that, boom, you can see it's created these joints for us. So there's a bit of a gotcha there. We need to just watch out for that, and that is the direction that they're traveling. And you can see here that the joints are actually starting at the top and coming to the bottom here. Well, I want them to start at the bottom and come to the top, because it's the top that I want to be the wavy part. So I'm just going to undo, and with that spline selected, you can right click in the viewport and you can just choose reverse sequence, and that's going to mean that the spline starts at the bottom here. And that was really my mistake, because I think that spline, when it's created, is based on the order in which you select those edges, and I did select the top one first. So we've got this one joint here for some reason. Let's just get rid of that. Okay, so select this spline, choose character, conversion, spline to joints, and you can see now that we have reverse the sequence, reverse the order of our points on our spline. They're now starting at the bottom here. If we select this joint here and switch back to our model tool, you can see there we have our joint train. Let's undo that. The only thing is, of course, it's just along that edge, and if we come to our top view, what we really want to do is grab that x-axis, just pull that into the middle there, and it just has to be approximate. So now if we come back to our lines mode, you can see there we go, we've got our joints. And the nice thing about using this approach is if we come through and select each one, you can see that all of the rotation values are all at 0. And the great thing with using the edges of the geometry, converting it to a spline, and then using the spline to joints, is that we know that those joints are going to be aligned really well with each edge loop, so we're going to get good deformations, and the length of them and the alignment is going to really match our geometry as well. So even if you have some geometry that is not quite as straight as this, it can still work. So I'm going to take these joints and let's just select all of them by holding down Shift. And if you come to the Tools menu, we've got something in here called the Naming tool. Now I've got this tool actually in my toolbar here because I use it all the time. Come over to the Tools in the Attribute Manager. And what we can do is we can prefix this with an L for left, and that's going to then name them left joint. And then for the suffix we can do underscore, and what we can do here is we can put a token in here, and if we put $N, it's going to then create a sequence of numbers for us. So we just click replace name, and you can see that's now named all of our joints. As I already mentioned, the joints themselves won't deform our geometry at all, and we can see that now just by rotating those. So what we have to do is we have to bind those to our mesh, and you can do that manually, or it's also an automatic process. If we select our antenna and then hold down Shift, come up to the character menu and come down and add in a skin deformer. So this skin deformer is the object that will allow us to deform our geometry. We also have to right click and choose character, and we have to add in a weight tag. And in this weight tag we can drag our joints, so we drag each one by one into here. So the way that it works with joints and the skin deformer is that each of these joints will have a certain weight that's assigned to the points on our mesh. And we come in and we can use the weight tool and we can paint these and say, okay, this joint 0 will only affect these points, and this joint 1 will only affect these points and these points. And by doing that over the whole of our mesh, it means that when I move joint 4, for instance, like so, it's only going to affect the points at the top here, and it's not going to affect the points at the bottom. Now, weighting meshes and painting weights like that is quite a long-winded, arduous process. And it takes a little bit of practice. But a certain amount of it is automated for us, so we don't really need to worry too much, especially when we're working with really simple geometry like this. So I'm going to delete that skin deformer, and I'm going to delete that weight tag. I really don't want to have to go through and weight all of this manually. If we select our joints here, and then hold down Control or Command and select the antenna, and come up to the character menu, and we have these commands, and we've got one here called bind. Now we can click on the little settings button here, and it will bring up a dialog for us, and the mode is based on the distance between our joints, how far the points are from the joint, the number of joints that we want to include. So if we say 1, it means that only one joint can be weighted to a certain point, but sometimes you might want to have 2 joints sharing it, so there's like a 50% weight. So one joint has 50 and the other has 50, which means that they will both deform those certain points. There's a few other options in here, but let's just click OK for now. Okay, and you can see that what happens is it's automatically added our weight tag. It's added all of those joints for us, and it's added a skin deformer. Basically, it's done most of the hard work for us. Now, of course, with more complex geometry, then you have to do this manually, but you can still use auto weighting, which will automatically set a lot of this up for you, but then you very often have to go through and clean it up. So what this essentially has done is it's assigned weight to each of the joints, and this is stored within this weight tag. Okay, we can come to the character menu and bring up our weights manager, and this is kind of like a spreadsheet, and you can see the joints in here. Come to the weights, and you can see that it's assigned all of these different weights to the various joints and various points on the mesh. We don't really need to worry about this for now. If you do want to see how the weighting is distributed, you can see it by using the weight tool. So if we come to the character menu, come down and select the weight tool. And then if we select the various joints, we should see the weight displayed in our viewport, and if we roll over you can see the values and which joints they're assigned to. But there's a bit of a gotcha here. Because we're using a symmetry object, the symmetry regenerates this and it hides the weights. But if we switch that off for a moment, and let's just press NC to come back to our simple shading. As I select each joint, you can see the color of each joint, and it shows whereabouts the influence of that joint is going to deform the object. So you can see that joint 2 is only going to deform it around where this green area is. And if you see that green somewhere down here, it means that it's calculated it slightly wrong, and you have to just remove that by painting it out with the weight tool. But in this example, I'm pretty much sure it's done a good job. We've got a nice simple mesh, a nice straight join chain, and you can see it's created all of those weights for us. Now we will do a little bit more on weighting, but for now I think that's absolutely fine. I guess the real proof here is that the deformation works correctly. So if we select, say, joint 3 and switch to our rotate tool, we should be able to grab this and rotate, and you can see it is rotating our antenna. Let's just undo that, and it's a good way to check that the deformation is working correctly. If I rotate this around and suddenly a point down here starts poking out, it means that the weighting on this joint is incorrect, and this one down here just needs to remove the weighting from there, and you can do that with the weight tool. So we can see that the deformation is working correctly. What's interesting to note, however, is that this joint chain is outside of the hierarchy, and these joints are now bound to the mesh, or really, I suppose, the mesh is bound to the joints. If we press play now, watch what happens. You can see that the joints don't move with our geometry. And that's kind of cool, because it means that you can use this set of joints to basically rig several objects, and they don't necessarily need to be within the same hierarchy. For this example here, we're going to keep it simple, and I'm going to just grab these joints and move them into the hierarchy as well. And I'm just going to put them right at the top here, just so that when the robot head moves around, the joints stay in relation to the antenna. It will just make more sense at this point. So the next thing that we need to do is add in some way of controlling these. You could go through and manually rotate them, and then select the next one, and then rotate this, and create some kind of wobble. But honestly, that's a very long-winded process, and we need to try and automate that. The whole point of this is to get that secondary motion for free, so that we can create these kind of rigs, and then when we animate our object, we get all of that really nice inertia and the secondary motion without any extra work. The other thing that's happening here is that when we move or rotate these joints, you can see that it's not deforming, or the antenna end, this sphere on the end, is not being part of that deformation, and we need to set this up so that they deform together. Now we could select all of our joints again, come down and just select the antenna end here, and come up to the character menu and just choose commands and bind that once again, and that will then create another weight tag, assign the joints, and another skin deformer. And now if we grab this and move this, you can see that it's kind of working, but we're getting the deformation happening twice. We don't actually need to do it this way. We can do it just with one skin deformer, and by having only one skin deformer, the performance is going to be better. By having two, we're going to slow things down. So let's just take this second skin deformer, and let's just delete that. And if we take the antenna end and we take that out of the hierarchy and just drop it here, and we take the skin deformer and we take that out and we drop that there, so these three objects are all in the same level of hierarchy. Now if we grab joint 3, we should be able to move that, and you can see that now that is moving along with it. We could also select our weight tag on the antenna end, and you can see that we've got all of the joints added. We don't really need all of them. It's only this very end joint that we need. So if we just take out joints 0 to 3 and just remove those, we can still grab joint 3 and rotate it, even though it's not in the list, because joint 4 and 5 are in the hierarchy, and they're the only joints that are really going to contribute to the deformation. So they're the only joints that we really need to have evaluated within this tag. And it's a very small difference, but when you've got very large complex rigs, keeping these kind of things streamlined will speed up the performance. Now we have the joints in place with our weight tags and our skin deformer set up. We need to look at some way of controlling this joint chain without having to manually animate each individual joint. And we're going to do this using dynamics, but as we work towards this setup, we're going to first of all need to set up an IK chain. Now, IK stands for inverse kinematics. What it allows you to do is it allows you to create a goal object which sits at this end of the chain, and you can animate that object, and then the joint chain will attempt to follow it as much as possible. And I suppose the best kind of real-world example of how this would be used is, for instance, if you have a character and they need to pick up a cup of coffee. It'd be much easier if you could just animate the cup and the arm and the hand and all the clothing, etc., all follow along and bend and deform in the right places, rather than having to use forward kinematics where you would start at the shoulder, then you would animate the elbow, then the wrist, and then you'd have to either use a constraint or animate the coffee cup some other way. So let's just see how that works, and the easiest thing to do is just to select the very first joint, and we come to the character menu, and then we can choose Commands, Create IK Chain. As soon as we do that, there's a couple of things happen. Adds this tag, which is an IK tag, and it also adds in this goal object. So if I switch to my move tool and grab this goal object and move it around, you can see it's doing exactly what I just said. The joint chain is trying to follow that goal and always point towards it, and it's folding in the appropriate places. Let's just undo. If we select the IK tag and come to the tag tab, you can see here it's saying use IK. The end is our end joint. And you can see that's joint 5. It's automatically added that for us. And the goal is our null here, and it's automatically created that null and added it for us. Now we don't need this in this example, so what I'm going to do is I'm just going to delete that, because we're going to be using dynamic IK. So come back to this tag. We're going to leave everything else in here as it is. Let's switch to the Dynamics tab, and in here we have the option to enable dynamics. So if we just enable this, you're not going to see anything happening in the viewport, but if we just press play, but before we press play, what I'm going to do in my timeline, I'm just going to click on the little film strip to mute all of that animation. Now let's just press play. Okay, and you can see that it doesn't really do a lot. So let's just enable that animation once again, pull out so we can see what's going on. Now if we press play, okay, so you can see as soon as we start to move, the chain just drops down, but we're getting this nice swinging motion. You can see we've automatically got this kind of secondary motion happening. It's just not really looking exactly how we want it to. Select the IK tag if it isn't already selected and switch to the Dynamics tab. Okay, and you can see here that we have a strength parameter, and we also have some drag, which will just tend to damp the motion. We have position hold and rotation hold. Now position hold and rotation hold will try and hold the joint chain in the original position and rotation, and you can see that position hold is set high, but rotation hold is set fairly low at 30. So we can come in here and we could set this much higher, say 60, and now it's going to try and maintain the rotation values that the joint chain was initially set to, but it will still have some dynamic motion. So if we press play now, okay, you can see that something's happening. We're getting some kind of motion. It's feeling a little bit stiff, but we're also getting some erratic movement going on in there as well. So we're starting to find the solution that we want. Let's just stop and rewind to the beginning. I'm just going to select and delete this spline that's sitting in there because we don't need that anymore. We only use that to create our joints. Coming back to this tag. Okay, so we've set that rotation hold quite high. Let's set that a bit lower, maybe 45. And let's just press play. Okay, now you can see we've got this kind of crazy thing bouncing around all over the place. It's a little bit erratic. Towards the end it seems to behave okay. It's still not really the result that we're after. Now, depending on the setup that you're working with, it really varies how you need to set these, and also, of course, the kind of result you're after. So the parameters that really we should worry about are the strength parameter, the rotation hold. And if we come to the bottom here, we've got this advanced tab. Fold this down, we've also got the number of steps. This is kind of the number of iterations, or the number of times that it calculates the dynamic. When we press play, and you can see, especially at this point, we've got this rather erratic motion. And what's happening is there aren't enough steps in the dynamics calculation for it to find a resolve, so it's a flipping and flopping all over the place and not finding the correct solution. And the only way we can do that is to sort of increase the accuracy, and by increasing the steps we will increase the accuracy, but it does also really change the result that you're getting. So if, for example, we increase the strength here, which is almost like a stiffness parameter, let's set that up to 40, and let's set the rotation hold to say 40, and let's just press play and see what we've got now. Okay, and it's even more erratic than ever, but it's slightly stiffer. I probably want it to be even stiffer than this, so we could increase these some more, maybe the rotation hold like 50 and 50. But you're still going to get that erratic motion because it's still, oh actually maybe it's just a bit too stiff now. Okay, so you can see that those values are quite sensitive. Let's put that back to 45. And here you can see we're getting a bit of that erratic jittering again. And we really don't want that erratic motion in our setup. So let's make these a bit floppier again, 40 and 40. And what we can do instead is this time we'll increase the number of steps. So you can see again we're back to this like fairly erratic result. Let's come down and let's set the number of steps up a bit higher. Let's say maybe 2. See what that's like. Okay, and you can see we've still got some vibration going on. Let's try this at 3. And you probably notice that as I increase the number of steps, the actual dynamic result becomes much, much stiffer. So you do need to balance and juggle these parameters until you get the result that you want. And you can see that with 40 and 40 and steps of 3, it really is a little bit too stiff. I want them to feel looser than this. So because I've increased the number of steps, I can probably get away with coming up here and reducing this down to say 35, maybe the rotation hold to around 35. Okay, and there you go. And now we're trying to get a result that's feeling pretty good. We can switch our symmetry on and we can see this on both sides. So you can see the symmetry object is mirroring the deformation as well, which is quite nice. So the dynamic IK is a really nice way of getting that secondary motion for free, but of course we do need to set up the joints, we do need to juggle with some of these parameters, so it's not an instant solution, but it is worth the effort because it means that when you animate your object you're going to get all that really nice secondary motion, and it's going to really aid the look and feel of your work. Now we did have to juggle the parameters a fair bit to get a stable solution there, and of course that is one way of fixing it, but there is another element that I didn't show you that could also be causing a problem here. And if we come back to the IK tag dynamics tab and fold down the forces tab here, you can see that the dynamic IK has this built-in gravity force, which is super useful. Also has this include list that we can drop forces into, so we can drop in particle forces such as turbulence and wind, etc., if we want those to affect the chain, which can add secondary motion even when there isn't any movement in the actual rig itself. But because we've got this gravity here that's constantly trying to pull our joint chain down, when it flops and we're using quite low steps, the gravity is quite a strong force and it does tend to take over, and we've got the simulation of the dynamics battling with the gravity, and this is one of the reasons as well that we get that erratic behavior. So if we took these steps back down to 1 but also set our gravity to 0, now if we press play and have a look, you can see that we're getting quite a floppy motion, a lot floppier than maybe desired, but we've totally got rid of that erratic behavior. And if we just right click on here to reset that back to the default setting, and we increase these up like so, you can see that it is indeed causing the problem again. So if we set that back down to 0, we should get the fix that we want. So sometimes just switching the gravity off can make the rig a lot more stable. It really depends on if you need gravity in your setup or not. So for example, in this setup we probably don't need it, but if we wanted our robot to tip his head forward and look down, then we would probably want the gravity to affect the joint chain so that the antenna themselves droop very slightly. So it depends on the setup whether or not you choose to include or exclude gravity. In this example I'm going to actually switch that back, and I'm going to set these back to 35 with 3 steps so that we're back to where we were before. So we've got a nice stable solution, It's just a little bit slower to calculate, but really we don't notice that lag. The steps aren't that high, so whether or not you use gravity, it really depends on the situation and the rig that you're working with. If you think about a real world setup, such as this, because there are so many robots walking around with wobbly antenna, but if we did have one, then really as it moved its head, the antenna would independently move around. They wouldn't be symmetrical as they are now. I mean, we're using symmetry. It's a quick way of doing it, but really it's not really giving us the best result. It'd be nicer if as it turns its head, the antenna move accordingly rather than both moving the same. Now we've set one of these up, we could go through the whole process. We could grab this, we could duplicate this, and we can duplicate this and then rebind them together and reset up our IK, etc. A bit of a long-winded process. Luckily for us, these kind of things are actually automated to a certain extent. First thing we really need to do is grab this whole group from the ear, and let's just take that out of the hierarchy, and I'm just going to drop this here. Okay, so it's only on one side. Now I know for a fact that this robot head is at world 0. You can see it is here in the coordinates manager. It's quite important working out where the root of your object is, because what we're going to do is we're actually going to mirror this geometry. It's really easy to do, and it does all of it for us. It does all the weighting and everything. It's not absolutely perfect depending on how complex the setup is, but this is a really simple setup, so this is going to mirror really easily. And all we need to really do is just grab the joint here, hold down control and grab this left ear. If we come to the character menu, we have the mirror tool. Open up the mirror tool. Okay, so we can see first of all the direction, and we want to mirror this and the world origin, the world axis. Now you can choose the root or the parent. There are lots of different options in here. If this null object wasn't at world 0, then you would probably choose root, because that's the root object. And we definitely want to mirror around that, but it really depends on your setup. We have some options in here, so we can clone them, or we can just mirror them, or we can mirror another object. So if we've got another object, we can drag that into this field here and it will mirror that. So if you had two different types of antenna, you could then use the other object. We're just going to choose clone, which is just going to basically create a duplicate of all of our selected objects. We can choose what we want to mirror, the position, the weights, the points, how we want the axis to rotate, and when we clone it, whether we want to clone any tags or animation. We want to clone the tags because we have an IK tag. We also have our weight tags, etc. Naming is just the same as the naming tool, but what we're going to do here is we're just going to replace L with R, because it's going to be the right hand antenna. The search option allows us to search through for weights. We'll just leave that at the default settings, and under the tool option we have the option whether or not we want to include children. And of course we do, because we've only selected the parent of these two hierarchies, and we can just now click mirror, and you can see that it's created all of our right joints, it's created all of our right geometry, and if we select our various tags, you can see that it has assigned the correct joints to each side, and that's all you need to do. So it's nice and simple. We can now press play, and now you can see, especially if we come to the side view, you can see that they're both behaving independently of each other. So that's pretty cool. So now we've created a really nice simple setup on one side, and we've learned how to mirror it onto the other side, and we've got this dynamic IK. And as I say, you can use this for loads of different things, anything that you need to be wobbling around. It doesn't have to be dead straight. Now we are going to cover rigging with joints in a little bit more detail in one of the other tutorials. But for now I wanted to add another small detail to this setup and just show you an alternative way that we could create a very similar result as using our dynamic IK setup. And what we're going to do is we're going to first of all come up to the MoGraph menu and come down and add in the MoSpline. And the MoSpline is a kind of spline generator. But it works with existing splines, or it can generate its own spline, and you can also use it with effectors, just as you can other MoGraph objects. So it's a really, really flexible object. So I'm going to just rotate this 90 so that the Z-axis is pointing up. Okay, and you can just see the tip of it here. So let's just pull this up. I'm just going to create one more little antenna in the middle of his head. Let's just come to our side view and press O to frame that. I'm just going to position it a little bit higher, just somewhere around there. Okay, now if we press H, you can see that he's got a huge antenna there, so it's going to be far too long for what we want. So I'm just going to switch to the simple tab here, and let's set the size of this to be a little bit smaller. Probably something like 50 or maybe 100. Let's try 100. Okay. Now the number of steps are the number of intermediate kind of points, I guess, or the number of segments that this is divided up into, and the higher this is, the more detailed it will be. We can probably get away with 25 or something for a short little spline like this. I mean, I think what have we got? We've got 6 along these joints. And also, just to come back to these, as far as the deformation on these, you can see that quite clearly. When they deform, you can see all the edges. It's quite low res, but that's normal. That's quite normal with deformation. What you'd probably want to do is just drop those objects into a subdivision surface, so that at render time it smooths that out. But you should always do your deformation before you do your subdivision. So it's a good idea to deform with fewer segments and then subdivide afterwards. You'll get a much smoother result. With this example, with the Mo spline, it's going to be slightly different. Let's just drag that into our robot head, so that's part of the hierarchy as well. And what I want to do now is I just want to add in a deformer. So to add a deformer to this object, we can hold down Shift, and we'll come up to the deformer menu, and in here the one I'm going to add is a jiggle deformer. Now we're going to go into quite a lot of detail about the jiggle deformer in some of the other tutorials, but I just wanted to add that in here because it's a really handy little tool for creating this kind of dynamic motion. You can use the jiggle deformer for creating cloth-like simulations, all those sort of things. Let's just switch the coordinates and set the Z of this to be 0, and let's also just rotate this to be 0 here. So the jiggle deformer, if we switch to the object tab, has all of these parameters, very similar in a way: stiffness, drag, the strength of it. We can flip down the advance and adjust the number of springs. So again, we're looking at a kind of dynamic solution using springs to create that inertia. Let's just deselect for a moment and rewind and press play and have a look and see what happens. Okay, and we're not going to see much until it moves backwards and forwards, and there you go, and hopefully you can see that. Let's just do it from here. So as the head moves backwards and forwards, you can see that whole spline is moving. And there it is, and you can see it is there. You can see the spline is moving there, and if we just keep going, you can see it then comes out of the other side. Now, of course, we don't want that to happen. What we want to happen is only the very top of that spline. We don't want the whole thing to do that. The easiest way to fix that with the jiggle deformer is to basically use some fall off. So we switch to the fall off tab. Let's just set this to be linear. And we can set this along Z, which it is by default. Let's set the fall off to be 100. Okay, so you can see where is our deformer, or our, where is our jiggle deformer? It's here. We really want it to start from here and end here. So we need to set this to be 50. And then just pull this up so that it sits more or less where our Mo spline is. Now if we just jump to this point, let's just press play. Okay, and you can see that what's happening is the very top of the Mo spline isn't getting any jiggle, but the very bottom is. So basically we have our fall off in the wrong direction. So we can just change this from plus Z to minus Z. Now let's try that. Okay, and there you go, and you can see that there is our Mo spline. Let's select the jiggle and let's just uncheck visible so we can't see that fall off. And on the Mo spline itself, if we come to the object tab, we can change the display mode so it just shows a line, and there we go. So now we can see a little bit more clearly what's going on. Let's just press play. And there we have the kind of motion that we're after. Now we can even fine-tune the shape of that by coming back to our jiggle, and if we come to the fall-off tab, at the bottom here we have the fall-off function. It's using a spline, and you can see in this spline graph we don't actually have any spline or any graph. And we can just click in here to add a point by holding down Control and clicking, and hold down Control and click. And we can then use that to change the shape of the fall off, which will actually change the shape of the jiggle deformation. If, for instance, we grab this and push this up like so, that's going to be the wrong way around, I think. But if we just press play now, you can see that we get this curve here. And really, we want that curve to come straight up here and then bend more at the top. So instead of doing it that way, let's just undo. Grab this point here, which is the maximum, which is why it refers to the top, because this is the maximum amount of effect from that jiggle deformer. And we can just make a kind of shape like this. And this shape here kind of represents the sort of shape that we're going to get up here. And you can see just by adjusting that, we can see how that's going to affect the deformation along our Mohs spline. And that's looking pretty good. So let's just rewind and press play. We can jump to this point. And there you go. And you can see now that we're getting this much nicer deformation. Now, it is worth bearing in mind that with this sort of thing, if we put an extreme amount of motion on it, the jiggle deformer will change the length of that Mohs spline. So it might get a little bit longer. Really extreme, it might drag all the way over here. It might become longer and shorter. So in some situations, it will be quite unrealistic. But for situations such as this, it's perfect. Really quick and easy to set up. Much quicker than doing the joint chain. And of course, we could use this Mohs spline within a sweep, or we could use it with something like a spline deformer, such as spline wrap. There are many different ways that we can use splines with our geometry. Select this Mohs spline. Let's just hold down the Alt key and come up and add in a sweep. And then we're going to hold down Shift and just add in a circle spline, like so. And you can see that if we render this, it's really thin. There is a little bit of a gotcha with using this. Let's just have a look what happens. Now we've got some geometry. Okay, so you can see that we're getting this weird result, not the result that we're after. And that's just to do with a few settings on our sweep. So what we really need to do on the sweep is we just need to select this, and we've got this option to rail and use rail scale. And the reason that it's doing this is because we can actually use the Mohs spline itself to set the size of our sweep, or the width of it. And under the simple tab we have this width option. If we change that, you can see that we can adjust the width of the generated geometry. In this example, that is actually a bit detrimental, and we can even fold this down and it will show us along the length of the spline how that width is mapped. But in this example, it's not working how we would like it to, so we can just select our sweep, uncheck to rail, and uncheck use rail scale. Okay, and now it's using the circle to set the width, which we can see is obviously huge at 200. So we just need to come in and set this to be much smaller, maybe 1.5. And we can come to the sweep itself, fold down the details here, and we can adjust the scale so maybe it just gets a little bit narrower towards the top. And now when we render it, you can see that we're getting the right result. And now when it deforms correctly. So there we go. We have two different ways of setting up a kind of dynamic, self-animating antenna. One using the Mohs spline and a jiggle deformer. And of course the jiggle deformer will work with a regular spline as well. And the other using joints and dynamic IK. Now the Mohs spline jiggle deformer combination is much quicker and easier to set up, but you do have a lot less control. The great thing about using the joints is that it won't stretch your geometry unless you actually want it to. You can even set them up with morphs and animate the shape of them, so you can have them actually, say you wanted the antenna to sort of flop down and droop as if he was feeling sad. You could add that shape in as a morph and you could animate to that, and you could still use the dynamic IK and it would still have that secondary motion. So there are advantages and disadvantages to each method, and I hope you found that useful. And these are some pretty cool tricks that you can use in your projects. So at this point we're going to save and we can move on to the next tutorial. Thank you.